All right, time to learn how to make a set flat. Now, it's really simple. The one we're gonna make is just a basic 4x8 flat. I actually filmed this video back in the old garage, so we're gonna check that out in a moment, but I just wanna talk about what we're gonna be doing today. Now, you can get really complicated with these. Just Google some images of bigger movies and you'll see these things can be like insanely detailed, and especially if it's like hallways and tunnels, they get really crazy. But we're just gonna focus on the most basic version of a set flat. It's literally just a 4x8 wall. We're not doing anything fancy or crazy. We're gonna start with the basics, gonna keep it simple. This will be perfect if you're doing like a movie set that's maybe, I don't know, just a room that has 4 walls. You're gonna butt all of these set flats together. Or if you're doing a home haunt or Halloween display and you just need to do the facade of the house, set flat's gonna be perfect for your needs. I'm also including a PDF to some blueprints for the set flat. That should be down below. There'll be instructions on how to get those. That way it'll have your buy list, your cut list, and all the measurements you need. You can just print it out. You don't have to be rewinding the video while you're building. Just have your handy dandy blueprints. All right, let's get to it. So what is a set flat? They're the walls of the set. This is what's gonna give you your basic structure. You can design these in all kinds of different shapes and sizes. We're just gonna look at building a simple 4x8 set flat. All right, let's look at the materials we'll need to build our flat. First is our 1x3 common board. Now you can also use 1x4, but 1x3 is cheaper and it'll make your flat lighter. Next we have our 1/8 inch luan. Now this comes in big 4x8 sheets. Sometimes it's also called underlayment at the big box stores, but it's basically just a piece of plywood that's 1/8 of an inch thick. Okay, so our basic set flat is gonna be 4 feet by 8 feet. That's 8 feet tall, 4 feet wide. 8 feet is normal ceiling height. Now let's look at the structure of our 1x3s. Now I know you're thinking those come in 8 foot lengths, so why don't we just run those all along the side and then we don't have to cut it at all. You can just cut these pieces, these little supports. We're gonna break the whole thing up in half, then break those sections in half again. Then we're gonna put some vertical blocking right down the center. So you're probably thinking, we just run these straight through, then we're doing less cuts. But here's the problem with that. Any weight that's going on this top piece, like let's say you have to extend your 8-foot ceiling to 10 or 12 and you're building another top piece that's gonna attach here, all that weight is gonna be pushing down on this board and it's gonna transfer onto the staples. And that has a better chance of failing than if you put it on top of this. This is why houses are built this way. You have your stud and your top plate. So all of the force that's going on here is gonna transfer through this piece into the stud and into the ground. So it's just safer. And think about where your staples are here. Your staples are going in here, so any weight that's going on there is just pushing the staples more into the material, whereas this way, all the weight is pulling those staples out. All right, so here's the blueprint for our set flat. As you can see, starting from the longest to the shortest, we have our 7 foot, 10.5 inch pieces on the sides here. Now that's subtracting 3/4 of an inch from each side for the thickness of this material, so 1.5 inches. And the next biggest piece are these top and bottom caps here. Those are 4 feet even. Then we've got our horizontal braces here. Those are each 3 feet, 10.5 inches. And then we have our vertical blocking, which come in at 1 foot, 11 and 1/16 inches when you subtract all the other material. Now, we could add all this up and divide by 8 to figure out how many 8-footers that we need, but we can also just do a really quick, simple, fast math. So the whole thing is 4x8, so we can just kind of round up. So here's 1 8-footer, 2, 3, and then these 4-footers, every 2 of those is gonna be 1. So there's 1, 2, and a half. So you can see we've got 6 circles. So we're rounding up, so that's gonna be 6 pieces of 1x3 material. Boom, fast math, we're done. All right, so we have all of our pieces laid out here. We have our sheet of luan, our sides, top and bottom, middle, and blocking pieces. Now I had to do a little bit of a math adjustment because the 1x3s were not exactly 3/4 of an inch thick. They were actually smaller, so that meant I had to make some of the other pieces bigger. I wanna take a quick second to point something out for those of you that are new to carpentry and woodworking. When you're referring to the dimension of lumbers, there's actually 2 types of dimensions. There's the nominal and the actual. Take for instance a 2x4. 2x4 is the nominal name for this piece of lumber, but that's not what the actual dimensions are. You would think that it's 2 inches by 4 inches, but in actuality, it's 1.5 by 3.5. The reason for this is the lumber mill will cut this to 2x4, but once it dries out and all the moisture is gone, the board actually shrinks down. Once the lumber is dry, the mills plane down the edges so they're nice and smooth, but in doing so, they cut off 1/4 of an inch on each side. Once you subtract these edges, what you're left with are the 1.5 by 3.5 inch dimensions. Same goes for a 1x3. Call it a 1x3, but it's actually 3/4 and 2.5. Now I just want to point out that this is a natural process, therefore it is not an exact science. Take this piece right here. It's not really 2.5 inches wide, it's actually a little bit shorter. So you want to measure your stock to see what your actual dimensions are and adjust your blueprints as needed. I always start with cutting the bigger pieces first, because if you make a mistake, that can then become a smaller piece, whereas if you cut all your smaller pieces and then you make a mistake on a bigger piece, you don't have any more longer pieces left. So start from the biggest, go smaller and smaller. I've got some wood glue here. Yes, this is a mustard container. I find that this is a really simple, easy, and very cheap solution for glue application because it's got a really fine point on there. You get a nice thin bead. Just my tip. Do what you will. I'm gonna start with the outside frame first, then work into the middle supports, and then I'll put in all of the blocking. Now I wanna emphasize using safety gear. I have my eye protection on because we are using a staple gun, and I have gloves on because a lot of the material is rough. Just be careful whenever you have gloves on to make sure it's not getting snagged on things or, you know, stapling your glove to the actual workpiece. To assemble the frame, we're going to apply some wood glue and then secure the pieces together with 2 staples. So for the middle braces, rather than measuring and marking every 2 feet, we've kind of already done the measurements, so I'm gonna show you a little shortcut here. You can actually take your blocking supports and use them as a guide. Now, as you can see, it's gonna automatically just line everything up for us, and we'll know we're in the right spot. Because sometimes if you're off just by a little bit, then that's gonna throw everything out askew, so I like to just work smarter, not harder. So what we're gonna do for the rest of these is we will mark our center line at 2 feet. The reason you wanna keep these centered is when someone's working on the other side of the wall, they'll know exactly where these studs are. So if they have to hang something up, like a picture, or they're mounting some piece of set deck onto it, they'll know exactly where that stud's gonna land. What you'll notice is we can nail the first one from both sides, but as we move along, we're not gonna be able to do that with subsequent ones. We'll still be able to go from here, but we're gonna have to toe nail. So instead of nailing from the end, we're gonna have to go at a 45-degree angle from one of the side faces and staple it in that way. Okay, so all that's left now is just to run some glue along the boards and staple on the front piece of Luan. Now, when using pneumatic tools such as nailers and staplers, you'll notice usually near the connection there's an indication of what the max PSI is for that tool. This one happens to be 120, but that's too powerful for this thin 1/8 inch piece of Luan. The staples are going right through it and it's not connecting our material. So what you want to do is adjust your compressor and lower it down to the appropriate level where you're getting below the surface of the Luan but not going fully through it. You'll want to experiment with some scrap material to find the right settings for this. The stapling schedule is about 6 inches around the perimeter and 8 to 12 in the field, which is the middle of the flat. All right, now that the flat is assembled, we'll go around and fill all the staple holes with some wood filler. This is also a great time to fill in any knot holes or other imperfections in the face of the Luan, and we'll wait for that to dry, sand it nice and smooth, and get ready to paint. The wood filler is all dry and sanded, so all that's left is to paint the flat. I'm laying it out this way, but you can also do it vertical if you want. I'm gonna be using some recycled paint. This is left over from another set. I wasn't sure what color it is, so I did a little sample. Turns out it's kind of like a darker neutral gray, which I think will be a good base for our sci-fi set, and then we'll add all kinds of stuff on top of it. All right, real quick, I want to show you a trick when you're connecting more than one flat and you want it to look like one continuous wall. Sometimes you'll get these seams on there, and this is a way to hide those really cheaply and quickly. Now, if you have more of a budget and time, you can mud and tape this like you would any normal home wall with, made of drywall, but I'm going to show you a quick method that's a little bit more budget friendly. And all you need is some masking tape and a little sandpaper. So what I'm going to do is the same way that you would with normal mudding and taping, we're going to use the masking tape just without the mud. Smooth that out there. And then what we're going to do is we're going to use the sandpaper to feather the edge so that when we paint this, it looks like one continuous wall. And I can still see it a little bit because it's not dry and there's a light blasting on it, but it's going to look great on film. Now to keep our flats upright, we're going to have to build some jacks. These are basically a very simple support that's going to screw onto the back of it. It's consisting of 3 pieces, and it'll form a triangle, which is the strongest shape in geometry. We're going to make it 8 feet, so it'll be the same size as our flat. but because this board is going to sit on top of the baseboard like in the flat layout, it'll be 7 feet, 11 1/4 inches. The bottom piece will be 3 feet, and then our cross brace will be about 6.5 feet. And we'll back this up off of the rear of the jack about 5.5, 6 inches, and we'll get a nice diagonal which will support it. So this will take any of the weight from the flat, which will be on the front here, and it'll prevent it from tipping over. And the way that this really gets locked in is you throw a sandbag on the back, and that holds it down, keeps it from tipping forward. Anybody bumping into it, all that pressure is gonna go through the jack into the ground and it won't tip over. Now, for our jacks, we're gonna be making a very common shape in set building, this little L right there. So we're gonna take 2 pieces of common board and we're gonna make an L. I have a pre-finished piece here. See how it's glued together and stapled? And this is a really nice, strong shape. You're gonna be building these a lot, so.
Learn it, know it, live it.
So our jack is gonna consist of 2 of these L pieces, and then we're gonna put them together and screw them in. Look how nicely that all just lines up. So you can easily just put a couple screws through there, hold this together, have our triangle brace. Everything's really easy and accessible, and it's nice and strong. Glue down the edge of the first piece. See, we have our little L right there. And then we'll staple down the edge to secure these pieces together. Now, I drew a line here just so that you can see where these things are gonna fit together. Now, what also helps with drawing those lines is I know exactly where to put some glue. Now, since this is our safety support, we wanna make sure it's as strong as possible. So we'll be putting some staples in through the bottom and then through the side to connect all of this together. We'll go ahead and do the same thing for our support brace. And we'll get the bottom of the support brace as well. And here's a look at a couple finished jacks. The one that we just built is in the middle. There's also a little green shorty one on the left and a stubbier one on the right. All right, now that we have our flat and our jack assembled, let's go ahead and put them together. So I've pre-drilled some screws on here. That way it's easier than trying to fumble and hold a screw and 2 pieces of wood at the same time. So what we're gonna do is just line this up with the center ridge here. Put our jack right like that, and we'll go ahead and screw it together. And last but not least, we got this sandbag for safety. Now what you wanna do is make sure that it's on the jack, like this. That's gonna put most of the weight on the jack and have the best holding power versus throwing the sandbag on the floor where most of the weight's going on the floor and it's just kind of pinning the jack down. You wanna make sure that that weight is being carried onto the jack itself. And that's gonna keep it from tipping forward. The brace itself will keep it from tipping back. I wanna demonstrate just how useful these little L pieces are. Let's say you're trying to hang some set dressing on the other side of the flat, but it doesn't line up with any of the actual frame. Well, you can mount one of these vertically, screwed into the middle support, or if you need it somewhere here in the field, you can screw from the top and bottom. Same goes horizontally. You can screw in from the sides or along any of these supports here. And now you have a solid backing to either nail or screw into. I want to just really quickly show you how you attach multiple flats together. Let's say we were building one big long continuous wall, or you wanted to put in a window or some other sort of set pieces here. I've made a little demo wall section, and we're gonna go ahead and screw it in right here. And as you can see, it really is so simple just to attach these together. And as I mentioned, each of these is a 2 by 2 foot section, so you can easily count how tall or how long a wall is. Pretty cool, huh? So there you have it. That's how you build a basic 4 by 8 set flat. Now, if your set's taller, you can use 10 footers or 12 footers or build components that go on top of the 4 by 8. Here's an example of a component from the set of Barry. This is a small little piece. They actually have their 1 by 3s on their side there. Yeah, there's a bunch of different shapes and sizes you can build, but this is all for today. Thanks for watching. I'll see you next time on the Geek Garage.